Welcome back to Amateur Hour. Today we're going to be checking the windings in this three-phase motor to make sure that we don't have any breaks or shorts in the lines. Okay, so to get started, we're going to go over here to this data plate. So as you can see here, this is a three-phase 9-lead motor and it's star connected. I'll show you a diagram later of what star connected means, but basically it's just how the windings are wired in relation to one another. So this is a dual voltage motor, which means it'll run at 220 or 440. So on the left here you can see the lower voltage configuration, and on the right you can see the higher voltage configuration, and that's which terminals you need to connect depending on the voltage that you have coming into the motor. So this was accurately wired for 220, but in order to completely check the windings, we have to disconnect all of these connections. So this diagram shows you what the data plate means when it says three-phase 9-lead star connected. Okay, so here you can see all of our terminals, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now these symbols right here are the circuit diagram symbol for an inductor. If you're familiar with DC circuits, this is the AC version of a resistor. So these inductors actually are the coil windings inside of the motor. And you can see these gaps between 6 and 9, 8 and 5, and 4 and 7. Okay, so in order to check the windings here, we want to make sure that we have equal amounts of resistance between 7 and 8, 8 and 9 and 7, because all three of these are connected. We want to make sure that we have a connection between 3 and 6, 2 and 5, and 1 and 4. So that'll let us know that the terminals can see the other terminals that they need to be able to. Also, we need to make sure that the coils don't have shorts between them. So we need to make sure this 3-6 coil can't see into the others, that the 1-4 can't see into the others, and so on. Finally, while we are doing all this checking, we need to make sure that the resistance values we get are similar. We need this coil, and this coil to have approximately equal readings. And we also need to make sure that the 7, 8, 8, 9, 9, 7 connections all have equivalent resistances. Okay, so the procedure for this is we're going to hook up the multimeter to our terminals here and measure the resistance, and we'll record them all, and that will tell us whether or not we have any problems with the motor. So the first one we're going to check is the 1-4 connection. So as you can see, we have a 1.5 ohm connection between those two terminals. Now we'll check the 2-5 connection, and we have another 1.5 ohms. 3-6 connection, 1.5 ohms. Alright, so now we need to check the 7-8-9 connection. 7-8 is reading 3 ohms, 7-9 is reading 3 ohms, and 8-9 is reading 3 ohms. Alright, so as you can see, we have very consistent readings between all of our coils. And now we just need to make sure that we have open lines where we expect to have them. So since we know that our 7-8-9 connection is there, we'll leave a probe on the 8 line and we'll check these other 3 coils. First the 1-4, and we have an open line on the 1-4. We also have an open line to our 3-6 coil, so we know that we don't have a short there. And finally we have an open line between our 2-5 coil and the center coil. So far no shorts. Finally, we need to check that we don't have any shorts between these 3 coils. So I've moved the probe to the 3-6 coil, and now I'm going to check that in relation to the 2-5 and the 1-4 coil. And we have an open line to the 1-4 coil, and an open line to the 2-5 coil. So as you can see, we measured open lines between these two, these two, these two, as well as these 3 externals with this final inner. So just as a final check, I'm also going to make sure that none of these wires are grounded to the motor's chassis. So to do that, I'm just going to stick one of my probes into this screw hole and make sure that it has good contact with the bare metal inside. And we have open lines all around. So that's how you check to see if you have any major faults in a 3-phase 9-lead star-connected motor. So that's how you take care of that. Some of you who come from DC land, like I do, may have been curious. These resistance values are really low for 220 and 440 volts. And the reason that they are is because these aren't resistors, right? These are inductors, because this is an AC system. And the neat thing about how AC works, and this is what makes RF circuits work, or I should say this is what makes RF circuits hard, is that as a signal oscillates back and forth between these poles, the magnetic induction of the coils actually increases the resistance that the AC faces as it oscillates back and forth through there. So we're measuring this with a DC ohm multimeter, and that does give us an accurate reading of the state of the coils. So they do make induction meters that you could read this with. You would set the frequency, and then you could put the probes in, and it would give you the inductance of this coil. I don't have one. I spend all my money on a Fluke 87 because I'm a DC guy most of the time. And also, for the purposes of this, knowing the inductance of these coils doesn't give you anything. We're just trying to make sure that the wires are how we expect them to be. So you might be wondering, we had these two hookup configurations on the data plate. And I'll kind of explain why that is the way it is, right? So if you're running this in lower voltage mode, which is 220 in this case, is what you're going to have is they're going to want you to short together the 1 and the 7 line, the 2 and the 8 line, and the 3 and the 9 line. And is what you're doing there is you're cutting out this section of coil, right? Because no matter what, you're going to hook up to 1, 2, and 3. And when you short 3 to 9, you're dramatically decreasing the amount of coil that the current has to pass through, because it bypasses this section of coil. And in fact, when you're running it in higher voltage mode, is what they want you to do is to hook up the 4 and the 7 line, the 5 and the 8 line, and the 6 and the 9 line. And you can see just from the drawing that that's much more coil, right? So you're increasing the amount of inductance or resistance in DC speak, and that's how they're accounting for it. If this was an Electroboom video, I would have shocked myself like 12 times. Of course, he's got a lot of subscribers. Hey Dad, you got the rescue hook?